Hello and welcome back. In this video, we're going to be learning what improper fractions look like and how to convert improper fractions into mixed fractions and what mixed fractions are. Let's first take a look at this fraction right here. So we've learned in the last video that fractions are just like division problems, and proper fractions, this is important, proper fractions have a numerator and a denominator, and the numerator is always less than the denominator. So for example, for 1/2, here's your numerator and here's your denominator. In order for the fraction to work, the 1 over here is less than the 2 because that would signify a part of the whole. But improper fractions, so these are proper. Improper fractions have a greater numerator than denominator. So for example, 6/5. And so while the 1/2 will look like this, and this is less than 1, right? The 6/5, it's still a fraction, but it's improper in that it's more than one whole circle. So if we were to represent 6/5 in a picture, it would look like this whole circle plus one-fifth. And this is because, if you think about it, 5/5 is equal to 5 divided by 5, which is equal to 1. So 4/5 is less, 4/5 is less than 1. 5/5 is equal to 1. So 6/5 is 1 plus that extra 1/5. And so that's why it's improper, because it's more than 1. So you can write, if you wanted to represent this concept right here, like this whole circle plus this one little sliver, you can represent it by saying 6/5, but you can also represent it in a different way. You could say that this is either 6/5. You could also say that it's 1 and 1/5, because that's basically saying, okay, here's the 1, and then here's the extra 1/5. These are the same number, and you can convert them into each other using simple calculations. So we just did this example. Let's try it again with this number. 7/2. Intuitively, it doesn't look like it's gonna be, it doesn't look like a right number, but if we try to visualize it, we can see how to rewrite it into a mixed fraction. So this is improper, and this is what we call a mixed fraction, because it's a mix between whole numbers and fractions. So 7/2. If we have 7/2, let's try to draw 7/2 right now. So here's 1, 2, 3, 4, 5, 6, 7. It looks like we have 3 whole circles if we match them up, and then 1 extra half over here. So here's 1, 2, 3, and then here's the extra half. So we would write this mixed fraction to be 3 and 1/2. That's good and all, but if we want to make this calculation a lot faster and make it, and if the numbers become more complicated in the future, the way we do this without having to draw out like the pieces is to actually do the division problem. So if you remember, you can convert fractions, if you can think about fractions as like division problems. So in this case it would be 7 divided by 2. Right, and then just like we were doing in long division, we're trying to see how many times 2 can go into 7. And it can go into 7 3 times, and then we have that one remainder, right? So we're just going to put that remainder over our initial denominator. So this number is the remainder, and this number is the original denominator. And then this is the result of the division problem. So that's how you convert an improper fraction into a mixed fraction. Let's see if we can do this again with another example. So I'm going to erase this and this. Let's try it for the problem 16 fifths. So again, let's look at it as a division problem. It seems like we can, or how about we try looking at it using the format that we know is better for this. So 5/16. So how many times can we fit 5 into 16 without going over it? Off the top of your head, you know that 5 times 3 is 15, so that's the closest we can get. And we have a remainder of 1 left. So our mixed fraction is going to look a little something. Well, the basis of it will be, the whole number is going to still be 3. And then what we do is we have the 1 as the remainder, so this 1 becomes the top of the fraction part, and then we take our original denominator and we put it here. So this is the mixed fraction version. 3 and 1/5. It doesn't seem that difficult, does it? Let's try this again with a different problem. So now we have 17 halves. So look at it as a division problem. How many times can we fit 17 into, or how many times can we fit 2 into 17 without going over 17? Well, 2 times 8 is equal to 16. And when we subtract, we get 1. 1 is our remainder, so what we get is that 8 is the body, 1 is the remainder, and two becomes our denominator. And then that's our answer, 8 and 1/2. So you should know that 17 over 2 is equal to 8 and 1/2, 16 over 5 is equal to 3 and 1/5. Now let's try this one more time with one last problem. And this one's going to be 30 over 7. When we do the problem, it's going to look like this. And know that you don't have to write all of this out. You could do this in your head if it's simpler and you can do that, but I'm writing this out so you can see the thought process. So how many times can 7 go into 30? The max is 4. That would be 28, and when you subtract you get 2. So the answer would look like 4 from here. 2 becomes the numerator, and 7 is still the denominator. And that's our answer right here. 30 over 7 is equal to 4 and 2/7. That's how to convert improper fractions into mixed fractions. Thanks for listening, and see you next time.